Hello class, welcome to today's lesson, which is 2.7, factoring by grouping, in which we will get to know this technique. You already researched a little bit about this one, so you should have an idea of how it works. So I'm going to go straight to the examples. Let's see. Example number 1. I'm given this polynomial 3x plus 6y plus bx plus 2by. And I'm going to explain to you how this idea of factoring by grouping works. If you notice, first of all, this doesn't look like anything we know how to factorize, okay? This doesn't look like a difference of squares or like a perfect square trinomial or like an addition or difference of cubes, or we look at it and we go like, I have no idea what to do, and that's understandable. So what we can do though is the following. We can group or associate some of the terms. In here we have 4 terms. For example, I can first associate these two and these two, and I try to factorize these two associations independently. Okay, for example, let's try these associations. If I try to factorize this, I can use the greatest common factor, which is 3. And I'm going to get 3 times x to produce this, and then plus 2y in order to produce this one, right? So this is a factorization, the factorization of these two terms. And I'm going to do the same in here. I get this plus, and if you notice, they share a common factor, which is b. So I choose it, and b will multiply x in order to produce this, and 2y in order to produce this. Okay, so now we have this new expression, which we may be calling a partial factorization, because we have already factorized at least partially. Okay, we have achieved partial factorizations. Is this a full factorization? No, because we have that plus in there, that plus, and that this cannot be classified as a factorization. But we may call it like this, partial factorization. By the way, this is my terminology. This is not standard mathematical terminology. Not that I know. Okay, and then if you notice, guys, what we can do next is look at this new expression and go like this. Okay, I have 2 terms. This is one term plus another term, and I notice that they share a common factor. What is the common factor between them? X plus 2y. You see, this acts, all of these parentheses acts as a common factor, and therefore can help me factorize. I'm gonna take it out as my common factor, like so, and this will multiply 3 in order to produce all of this term. Can you see? And then plus b. Why? Because this parenthesis times b will be producing this. Can you see? I want you to see all of this thing, all of these parentheses, all of the numbers inside as a single unit. You see? So if you look at that, it acts as a common factor between these two terms. And therefore, we have achieved a complete factorization by grouping of this polynomial. Okay? So that's how it works. That's the basic idea. By the way, you may be thinking, well, which ones, if I'm given this original expression, which ones do I have to associate? Like, she's going to be this and this, or maybe this with this and this with this, you see? Or maybe another configuration, maybe this with this and this with this, okay? And what is the correct answer? The correct answer is that at first sight, you don't know. Okay, you have to try several of them until one works eventually. And you know, with practice, you can get very familiar with these ideas, and you can get them done pretty quickly. Okay, but the more you practice, the better, and you will get more natural with these ideas. Let's try another one. Example number 2. We have 15x squared plus 20xy plus 18nx plus 24ny. So same idea, we have 4 terms. It doesn't look like anything we know how to factorize, so we may try factoring by grouping, and hopefully it will work. Does it have to work? No. Okay, because remember that not all polynomials can be factorized in this way. Not all polynomials can be factorized. Those we call prime, so just make sure about that. Not all polynomials have to be factorizable. So let me try the same thing as before. Let me try to associate these two and these two, and let's see if that works. So when I look at these 2 terms, this one and this one, I can see quickly that the greatest common factor will be 5x. So let's factorize all of this by using this common factor, the greatest common factor. So I'm gonna get 3x in order to produce this. This times this will give me this. And 5x times what will give me this? That's gonna be 4y. Make sure about this, guys. Plus, let's factorize this too, if we can. Maybe we won't be able to. So the greatest common factor will be 6n. That multiplies x. No, sorry, 3x. This times this will produce 18nx. And 4y. This times this will produce this. So I have already achieved a partial factorization of my original polynomial, or my original expression. Remember that all polynomials are expressions, algebraical expressions, but not all expressions are polynomials. Okay, and now I look at all of this term and all of this term, and I notice that they share in fact a common factor, which is all of these parentheses. You see, it's the same factor. So I'm gonna take it as a single unit. I'm gonna think of it as a single number, whatever it is, I don't care. If they are the same, then they are the same factor. That's it. So I choose it. I open up my parentheses to factorize, and I go like, okay, what should I put here such that all of this times this number in here should give me all of this? Well, that's going to be 5x. It's very simple. And the same in here. We have a plus. And what number should I put here such that this times this number should give me all of this? That's going to be 6n. And as you can see, we are done. You look at this factor. You look at this factor, and then you realize that they are prime factors. They cannot be factorized any longer. So we have achieved a complete factorization of my original polynomial. Perfect. Let's see one more. This one's a little more complex, I think. Number 3, x squared plus 8x plus 16 minus x c to the 2 minus 4 c to the 2. So now we even have more terms. We have 5 terms, and we can have as many as they throw at us. So let's see how we can handle this one by trying factoring by grouping or factoring by association. Well, when I look at this, I can see that it looks like some of those trinomials we have factorized already. It looks like a perfect square trinomial, right? Maybe it's not, but it looks like so. So I'm gonna isolate it. I'm gonna bring it down here, and I'm gonna make sure that it's a perfect square trinomial. So this number can be the square of x, this number can be the square of 4, and this number is twice the product of this and this. So in fact, this is a perfect square trinomial, and the factorization will be x plus 4 to the square. Make sure, okay? Now, by the way, something I forgot to tell you, I think, it's that even though we can factorize this up as a perfect square trinomial and use this technique, the technique for factorizing a general trinomial of second degree also works, right? Like you open up two parentheses and you try to guess two numbers, one in here and one in here, that should give you x. So the only possibility is clearly x. X times x is x squared. And then you're gonna think of another two numbers, this one and this one, which multiplied together will give you 16. So you may say, okay, 4 and 4, that's one possibility, right? And I mean plus 4 and plus 4. And then the product of these two plus the product of these two will give you the one in the middle. So it also works. So you can employ this technique with any trinomial, basically. That's what I'm trying to say. So all of this trinomial, the factorization is this. And I could as well erase this thing because I already know that fact. And I can write it down. All of this is equal to x plus 4 to the square minus all of this. And now I may be thinking, okay, what about these two? These two terms, do they share common factor? Well, yes, I'm seeing the c squared right there. So I'm gonna take it out and factorize all of this expression by using c squared. I'm gonna take out a minus c squared like so. Okay? And here I'm gonna try another possibility for you to understand two different ways to do this. So I can choose minus c squared as the common factor, the greatest common factor, and I proceed. Minus c squared times what should give me all of this thing. Well, that's gonna be x, right? And what number should I put here such that I'm gonna get all of this? Well, that's gonna be plus 4. Why plus? Because we already have a minus here. So you have to pay attention to what you're doing. Minus c squared times plus 4 will give me minus 4c squared. Okay, so we now have this expression. Okay, it has two terms. This is one term. This is another term. Remember that terms are separated by either pluses or minus. In this case, it's this one. And I can see that they share a common factor, which is x plus 4. Okay, so I start. X plus 4 times what should give me this? Well, times x plus 4, right? When I multiply x plus 4 times x plus 4, I'm going to get x plus 4 to the square. And x plus 4 times what should give me all of this? Well, that's going to be minus c squared. X plus 4 times minus c squared will give me this part. And I'm done. If you notice, this is a full factorization. Don't let these two parentheses scare you. You can actually erase them. In this case, there's no problem. And you can either put them or erase them. In this case, it's irrelevant. We have achieved a full factorization. Why? Because I can read all of this expression now as some factor times another factor. And that's it. Now, another way in which I could have done this is the following. I was at this point, right? Like, okay. I'm gonna select this. I don't want you to pay attention to this anymore. Let's suppose this is not here for the moment. And I'm gonna go from here, and this is gonna be my next step. So if you remember, I mean, if you notice in here, I said that the common factor between this term and this term was minus c squared, which is perfectly valid. But I can also do this. I can say that the common factor between this term and this term is plus c squared. That's perfectly fine. Plus c squared. And I open up my parentheses and I try to write a binomial such that c squared times this binomial should give me these two terms. So c squared times what should give me all of this thing. Well, that's going to be minus x. Why? Because plus c squared times minus x is going to give me minus xc squared. Make sure. And the same for the other. C plus c squared times what number with its proper sign should give me minus 4c squared. Well, that's going to be minus, first of all, because plus times minus should be giving me minus, and 4. Plus c squared times minus 4 is going to be equal to minus 4c squared. Okay? But now if you notice, uh, it looks as though when you look at the final product, when you look at all of this, you have this x plus 4 times x plus 4, right? Which is the same as this, plus c squared times minus x minus 4. And if you look at this term plus this other term, they don't seem to have a common factor, because my factors in here are x plus 4, and my factors in here are c squared and minus x minus 4. So how can we reconfigure this, or how can we do something in order to achieve full factorization? Okay, I'm gonna show you this trick. You can fix this in some cases by a double multiplication by minus 1. I hope I don't confuse you with this. Look, you can multiply any number. For example, let's talk about number a. I can multiply it 2 times by minus 1, and I'm gonna still get a, right? Because a times minus 1, that's gonna be minus a, and then minus a times minus 1 will be clearly a, right? So when we multiply a number by minus 1 2 times, we are actually not changing that number. So we can always do that. Always. Under any circumstances, we can do this. All right. So what's up with this? Well, why am I talking about this? Because by applying that little trick to this number, I can fix that thing. I can fix this in order to factorize it. Let's see how. I'm gonna continue here. So it's gonna be x plus 4 times x plus 4, or x plus 4 to the square, it's the same. And I'm gonna apply such thing I told you. I'm gonna apply c squared times minus x minus 4 times minus 1 times minus 1. Okay, so let's start. I'm gonna first multiply these two. Okay, this factor and minus 1. I'm gonna multiply them. So what's going to happen? When I multiply minus x minus 4 times minus 1, I'm gonna get x plus 4. Make sure of what I said. It's very simple to see. Okay, isolate these two things, isolate them, multiply them, and you should get x plus 4. It's very simple. Okay, and so I have plus c squared plus c squared times x plus 4 times minus 1. And now this minus 1, I'm not gonna multiply it one more time with this factor, because I'm gonna go back to the original place. I'm gonna go back to square 1. So no, I'm gonna instead multiply minus 1 with this one, with the plus c squared. Okay, that's what I'm gonna do. So I'm gonna get equals x plus 4 times x plus 4 and then minus 1 times plus c squared. That's going to give me minus c squared. That multiplies x plus 4. And now if you notice, we have the same expression as this one. You see? Compare them. And basically, we can do the same we did in here, okay? And the problem is done. So I just wanted to tell you about this little trick in mathematics, the double multiplication by minus 1. And that sometimes can help with factorizations, you know, or with many other things. You know, it's a very common technique in mathematics. Let me just very quickly tell you another example of this trick. Let's suppose we have x plus 3 times y, and then maybe we have let's say we have minus x minus 3. Well, let me put it closer to the plus sign. We have this, and then we have minus x minus 3 times w, okay? And I tell you, please factorize this expression because it's clearly not factorized. You may look at both, you may look at this term, you may look at this term, and you may conclude that they do not share a common factor. But that's only an illusion, so to speak, because you can apply the trick that I just showed you, the double multiplication by minus 1, to either one of them. I'm going to do it in here, and you can find that they actually share a common factor. So I'm going to do it. So we have x plus 3 times y plus double multiplication by minus 1. So I'm gonna go minus 1 times minus 1 times minus x minus 3 times w. And one of these minus ones, I'm gonna use it to check to multiply with this one. Okay, I'm gonna multiply these two, this minus 1 and this factor, and this one I'm gonna use it with this one. So I'm gonna get x plus 3 times y, and then we have plus, and then we have minus 1 times minus x minus 3. If you do that independently, you will get x plus 3. Convince yourself, do it separately or whatever. It's very simple. And when we multiply minus 1 times w, I'm going to get minus w quite clearly. And now we can see that, in fact, my original expression, which is the same as this, actually has a common factor, which is the x plus 3. I take it out, I choose it as my common factor, and then I can factorize in this way. X plus 3 times y to produce this, and x plus 3 times minus w in order to produce this one. And I'm done, guys. You see, this is the factorization of this original expression that at first sight looked like it had no common factor between this term and this term. So double multiplication by minus 1 is always a good technique. Okay, guys, so I think that's it from me, and you can begin working in the exercises. Thank you.